Good afternoon. Thank you for joining the Georgia Climate Scholars Climate Communication Workshop with Dr. Marshall Shepard. In this workshop, you guys will be learning tips and techniques from Dr. Shepard, and you guys are going to be able to practice your skills with exercises throughout the workshop. My name is Leslie Townsell, and I am a graduate assistant for the Georgia Climate Project. The Georgia Climate Project is a partnership between 9 universities in Georgia, the ones that you see here. A special thank you to our funders. So the goal of the Georgia Climate Project is to answer 2 questions. What does a changing climate mean for Georgia, and what can we do about it? Now, we do that through our information portal on our website. The Georgia Climate Project Climate Scholars is a new initiative of the Georgia Climate Project to cultivate a community of scholars from the GCP partner schools across the state. All undergraduate and graduate students and recent alumni who are interested in climate change from GCP partner schools are welcome to participate in any and all of our events. Okay. Make sure you follow us on social media. You can find us on Instagram. You can find us on Instagram and Facebook, Georgia Climate Project, and then you can find us on Twitter at GA Climate PROJ. I'm sure everyone is familiar with Zoom. We are in a webinar setting, so as audience members, your audio and visual will be off. Please use the Q&A and chat function to communicate. And I'm just going to give a quick bio of Dr. Shepard. So Dr. J. Marshall Shepard is a leading international expert in weather and climate and is the Georgia Athletic Association Distinguished Professor of Geography and Atmospheric Sciences at the University of Georgia. Dr. Shepard serves as director of the University of Georgia's Atmospheric Sciences program and full professor in the Department of Geography, where he was a previous associate department head. Prior to UGA, Dr. Shepard spent 12 years as a research meteorologist at NASA Goddard Space Flight Center and was deputy project scientist for the Global Precipitation Measurement, GPM mission, a multinational space mission that launched in 2014. Dr. Shepard is frequently sought as an expert on weather, climate, and remote sensing. He routinely appears on CBS, Face the Nation, Nova, The Today Show, CNN, Fox News, The Weather Channel, and several others. Dr. Shepard is also the host of the Weather Channel's award-winning show, Weather Geeks, a pioneering Sunday talk podcast show and contributor to Forbes magazine. Dr. Shepard received his BS, MS, and PhD in physical meteorology from Florida State University. All right, Dr. Shepard, I'm going to hand it over to you.
Great. Thank you so much, Leslie, for that introduction. And it's really an honor to be here speaking with you today. As you have heard, I am going to walk through some things that I have kind of found to be successful over the years as not only a scientist, but someone who broadly engages in the public on science. I think it's increasingly important that students become what I call end-to-end scientists. Right now, many of you may actually be studying some aspect of science, and you are learning to give talks, write papers, do research, go to conferences, write journal papers, write grants, and then get on the treadmill and do that all over again. What graduate programs in academia or the ivory tower do a good job at is producing scientists that know how to do those things, but it doesn't do a good job producing what I call contemporary scientists. Virtually very few graduate programs have training in media training and public speaking and engagement with policymakers and the things that I believe we need to do in this current era of science. I want to dismiss right now. I want to sort of come in and sprinkle an academic bomb on this idea that doing public outreach and engagement and social media is all that extra stuff. It's not. It's a part of our engagement as science. I've been quite successful in engaging in all of those, and my science hasn't suffered at all. In fact, I was recently elected to 3 national academies. And it's on the heels of, or on the philosophy of, engaging in the peer review literature and the typical ivory tower metrics, but also broader engagement. So with that context, let me go ahead and share my screen and get my slides started. Can you see cupcakes? Hopefully so.
Yes, we can.
Very good. And by the way, throughout the discussion, I mean, I've got a couple of exercises later in the talk, but I also will engage and ask questions at certain times throughout this. So be prepared to take your mics off of mute and bring your screens forward off of the icons, because it's really important to have this being an engaging discussion. I start with this slide because I think it's just a brilliant example of science communication. And what I mean by that is that when we talk about a tornado watch and a tornado warning, it is one of the most confusing concepts that I deal with for the public. Many people will often get the two confused. I'll tell you a little story. My daughter was in a science Olympiad a few years ago, and one of her teammates at the state science Olympiad, the question was, which of these two is the more severe situation from a weather standpoint, a tornado watch or a tornado warning? And someone on the team buzzed in and said, tornado watch. And I'm like, no, it's the other. I said, why did you let the kid whose dad's a meteorologist buzz in on that one? But in all seriousness, afterwards, I talked to the little girl, and she said, well, Dr. Shepard, I thought tornado watch meant you're watching the tornado, and tornado warning meant you're actually warning that one may happen. In fact, it's the other way around. A tornado warning is the more severe situation. That means either Doppler radar has identified a rotation on radar or someone has seen a tornado. So I saw this little sort of meme by meteorologist Brad Panovich, a colleague of mine in Charlotte, North Carolina, and I thought it perfectly communicated the difference. On the left, you have the ingredients for a cupcake. So we have cupcake watch. On the right, we have an actual cupcake warning. So I just thought this was a really good example of sort of taking something that confuses the public and simplifying it in a way that I guarantee you now, you all will never think about at least a cupcake or perhaps a tornado watch and warning differently after seeing this meme. And so I'll loosely entitle the talk today, Tips for Communication Science to People Who Are Not Scientists and on Social Media. If you look at this sort of statement I make on the left there, it sort of echoes something that I started off my discussion with you about. I said, I believe that too many scientists are comfortable in the ivory tower, journal space, and conferences. However, a gale of misinformation rushes in to replace the void if scientists are not communicating to the public, stakeholders, and students. Yet there are scientists that will say, well, I don't know how to do those things. I'm uncomfortable doing those things. It's extra stuff, or it's not scientifically rigorous, or it's so popularizing to do those things. I believe those are all just prehistoric ways of looking at being a professor or a scientist in the year 2021. I just think that's, I kind of think of the Flintstones or pro dinosaurs when I think of that kind of thinking, because I think we have to engage. Let me just briefly, before we pause, let me look at the chat here. I see a chat there. Okay, good. I just wanted to make sure that wasn't anything from me. We have to engage. You see the image on the top right, that's me on the set of the television show, The Weather Geeks, that I hosted for many years for the Weather Channel, and that we now do it as a podcast. You can see from my sort of coordinates down there, I write for Forbes magazine. I've been the president of the American Meteorological Society. You can follow me on Twitter. Please do, if you don't, at Dr. Shepard 2013, because I engage in social media. And again, I don't consider it extra stuff. I consider it part of my scholarship. I consider it part of what we as scientists need to and should be doing. And so today, I want to walk you through some tips and even partake in a few exercises to help you become better scientific communicators and diversify your portfolio as a scientist or as a scholar. It's increasingly more challenging for us as scientists because we deal with this scenario right here. We have this poor scientist on the left with all of his equations and background and training, and then you have this guy on the right with a cell phone in his hand saying, no, some guy on Twitter says you're wrong. That's the world that we currently live in. It doesn't matter whether we're talking about climate change, a tornado watch, or COVID-19 and vaccines. The era of experts, what I call Twitter tech, Wikipedia University, or Blog State University, presents challenges because people think they just can do their own research. I'm sure you've heard that. And that Google or Wiki search is just as powerful or as valuable to them as our years, sometimes years and decades of training as scientists and so forth. And so you heard me mention that we are in an era of degrees from Wikipedia University, Blog State University, or Twitter tech. And this is a reality that we now face. In fact, this still captures my attention. 2017, Hurricane Irma was approaching the coast, and one media outlet actually dedicated a journalist in their organization just to keep up with the list of misinformation about Hurricane Irma, where it was going, how strong it was going to be, because though the official information was coming from the National Hurricane Center, there was all kinds of information and innuendo floating around about Hurricane Irma. So I just thought this was a powerful example of something that we are increasingly facing as scientists in this current era. So I want to start with the big challenges. The Dunning-Kruger effect, cognitive dissonance, confirmation bias, internet and social media, these all present big challenges. So I want to stop right here. Is there anyone, and let's all come on camera for a second, and I'm going to put this into sort of the gallery mode. Come on camera and unmute yourselves. Does anyone know what the Dunning-Kruger effect is? And if so, please tell me. And if you don't know, that's fine. But if you think you know, please come on and online and tell me what your understanding of Dunning-Kruger effect is.
We got one hand raised. Let me see if I can let someone.
Yeah, if you can sort of bring their audio forward.
Absolutely. Yeah, if anyone in the room is interested in turning their camera on, just raise your hand one more time and I can give you permission.
Oh, are you controlling that on your end, Rachel?
Yeah, just to prevent any Zoom bombing. Yeah.
I see.
All right.
So it looks like Katie and Rohan actually have their hands raised. So Katie, why don't you go ahead, Katie. Why don't we hear from Katie first?
Oh, my bad.
Sure.
Oh, I'm sorry. Go ahead, Katie.
So I was actually just teaching some of my students this, and they watched one of your videos. But the Dunning-Kruger effect, I think the simplest way for me to describe it is this effect where when we know very little about something, we have a tendency to overestimate how much we know. And the more we learn, we realize that there's this vast amount that we actually don't know. And so it takes knowing a lot to actually know how much there really is to learn about something.
Yeah. And Rohan, would you add it, or did you have anything else to add to that?
I just remembered it was like a curve, and then when the people that didn't know very much about a certain topic, they would be very confident in what they would say. Mm-hmm. And then the more you know, the confidence went down.
Exactly. And so I think you both all are hitting on this idea that Dr. David Dunning and Dr. Justin Kruger, two Cornell University psychology professors, published on when they sort of introduced this concept of the Dunning-Kruger effect. So the sort of textbook definition is a cognitive bias in which unskilled individuals suffer from illusory superiority, mistakenly rating their ability much higher than is accurate. And I'm almost certain that each of us has experienced that in some way. Heck, I do it every time I watch football, because I'm sitting there yelling at the coach, saying, "Why did you run that play?" Or why did I'm exhibiting some degree of Dunning-Kruger effect. I'm not a football coach. I know a little bit. I know more than a little bit about sports, but again, that coach has certainly more experience and training and has studied film and thought about those issues for that game more so perhaps than I have as someone that's just casually watching the game as a fan or an alum. So one of the things that I think we all should be aware of is that we probably all exhibit Dunning-Kruger effect at some point in our lives. It's just a matter of the relative scale of how we exhibit it, because there are some people that literally are exhibiting Dunning-Kruger when it comes to climate change or COVID-19 vaccines, and they have dangerous consequences with that Dunning-Kruger effect. Now, this is interesting. When we think about cognitive dissonances and so forth, there was a Nature climate change study that found that for people with increased scientific literacy, they are actually better at fitting evidence to their own narratives, ideologies, or cultural perspectives, even if they are flawed or counter to the consensus position. This is important because there's often a narrative that when we are dealing with people with misinformation about climate change or vaccines, that we are dealing with people that are just scientifically illiterate or perhaps have deficiencies in their knowledge. But this study suggested that there are some fairly scientifically literate or intelligent people that, twist and turn the data because of that level of intellect. And so that's just something that you should all be aware of when we're thinking about this scientific communication journey that we're about to embark on. I'll use the lens of weather fatalities. When I give a talk about extreme weather, I often ask the question, what kills more people in a given year in the United States from a weather standpoint? And undoubtedly, I get hands raised and people will say, oh, I know, it's tornadoes or it's hurricanes or lightning strikes. When in fact, if you look at this data, and again, this is 2015 or so data, but it's actually similar for 2020. I've seen the recent data. It's actually over a 30-year average heat. It's just simple heat, and then followed closely by floods. So heat and floods are actually the most deadly weather in the United States on a per annum basis, not the sort of more television sort of telegenic events like hurricanes with my good friend Jim Cantori or some other meteorologist standing on a beach sort of in those big winds from a hurricane or a tornado, because we get these visually stunning cell phone images of a tornado crossing the interstate. It's just heat. And so, there are these perceptions created. And so here's some other sort of interesting sort of perceptions and cognitive challenges that people face because they have these perceptions or biases. For example, many of you may have heard from a grandparent or an uncle about heat lightning. There's no such thing really as heat lightning. So I'm sure some of you've heard the term. People say, oh yeah, it's just the heat lightning caused by the heat of the day. When in fact, it's just lightning far off in the distance, too far away for us to hear the thunder. People have perceptions about it not being cold in deserts. They think typhoons and hurricanes are different. One that I hear as a meteorologist all the time is that we're wrong 50% of the time or more, when in fact, we're right most of the time. People just remember the handful of times that we're wrong. It's just like a poor field goal kicker can make all of the field goals in a football game all year long. But if they miss the one in the bowl, that's the one that people will remember. And that's the same thing with weather forecasting. And there are a host of sort of biases and misperceptions that we deal with in my field of weather, but they're also in climate science as well. And so, when we talk about these cognitive dissonances, we talk about Dunning-Kruger effect, or we even talk about the other thing that I want to go back to, which is confirmation bias, this idea that we seek information from sources that sort of already align with what we believe or think. These introduce challenges in terms of the already daunting task for scientists on how to properly communicate science. And so that's why in 2022, November 22, 2016, I actually wrote this article in Forbes as a part of my contribution. I write for Forbes, as I mentioned earlier. I wrote 9 tips for communicating science to people who are not scientists. And the basis of this lecture or this class or this webinar is rooted in this article. And so the article's out there and it's available. So you'll have it as a reference point as we walk through this discussion today. So the first sort of tip is to know your audience. Know your audience. And you might be saying, well, why do you have a dartboard on the screen, Dr. Shepard? And the reason I do is that one of the best climate communicators I know is a guy named Tony Lacerowitz at Yale. And he was on my show, Weather Geeks, one time, and he said, if you don't know your audience, it's like throwing darts at a dartboard with the lights off. And that really resonated with me because I see this mistake all of the time with scientists. We give the exact same lecture that we would give to our professional society or to our sort of science attentive colleagues. We give that same lecture to the Rotary Club, or we give that same lecture to a church group. That's not knowing your audience, because they're not really going to understand some of the jargon and the trend lines. And I'll say a little bit more about the jargon and trend lines a little bit later. That's a fundamentally flawed approach. I mean, if you should have very different talks for different audiences. To give you an example, and I'm going to open this up right now, Rachel. So again, if you can monitor the sort of hands being raised. Here are 3 different depictions of sea level rise associated with climate change. I would give each of these in different settings or audiences. So what I would like to do now is to sort of pause in this moment and have you think about each of these. These are 3 different representations of climate change. And let me give you sort of some background on each one. One, the top left is the road leading from Savannah to Tybee Island. There wasn't a storm. This was a king tide flood. 2, we have satellite data from NASA showing observations of sea level rise. And then on the top right, we have a social vulnerability index showing coastal counties that are most vulnerable to sea level rise. So let's open it up now for some sort of class exercise / discussion on how or where you think each of these or any one of these might be appropriate from an audience standpoint. So I'm just anyone that, because I can't see you. So you pick one of these and tell me an appropriate audience. Anybody raise? Okay, Sophia. I saw Sophia, and then we'll go with Julie.
Hi, I think that the one on the top left with the picture of the road leading to Tybee Island would probably be best to show to the general public, so that way they could actually see the impact. So if like you were showing it to someone who didn't have any experience with science or with data like that.
Yes, I think you're absolutely right. And as you see, the logo there, that actually did appear on the Weather Channel. And so it really conveys, particularly for someone that maybe has been to Tybee Island and has driven on that road, wow, that I've never seen that roadway that way. And that wasn't from a hurricane coming through. So absolutely, Sophia. Julia, what are your thoughts?
I was actually going to say the same thing on that one, but I'll pick the one below that. I would think that the charts would be more for professional people that would understand the whole chart concept.
Absolutely. Yeah, this is a chart showing sea level change. And then again, this is an opportunity for me to really focus on something. Don't assume when you show a graph, and we as scientists show a lot of graphs in our presentation, and we assume that people look at them and see exactly what we see. But you'd be surprised at how many people in that audience don't. You'd be surprised at how many people really don't necessarily even understand, though it says sea level change here, they don't understand that this is, minus 20 millimeters is sort of a substance versus a rise. You'd be surprised at how many people, when we say positive trend line, as I'll say in a minute when I talk about jargon, the word positive to them means good, right? And so that means, oh, that's good. It's a positive trend. When in fact, it just means that it's increasing over time. And so again, when I look at this chart of satellite data of sea level, my scientific trained mind knows exactly what I'm looking for. But if you are going to show a trend line or a graph like this, and I try to show as few as possible in public settings, I take the time and try to explain every little nuance. Well, what's that pink dot mean? Or what does that up arrow mean next to 3.41? Because people don't interpret it that way. Does anyone have any thoughts? Thank you, Julia and Sophia. Does anyone have any thoughts on the SOVI index, who you might show that to?
Sure, I can jump in here.
Please do.
I
And
feel
who's
like
speaking?
anybody
Please
who
introduce yourself, because I can't see the full gallery of who's speaking at any given time. Sometimes I can.
all right, sure. I'm Max. I'm a PhD student in plant biology here at UGA.
Okay.
I feel like anybody living in one of those coastal communities would be really interested in seeing a figure like that, but maybe not so much if you're living elsewhere in the country.
Yeah, so you might focus that if you're giving a talk in Chatham County, right, or St. Simons. Or this actually also might be a really good figure to show to a group of planners and policymakers in those counties as well. So absolutely, I think you all sort of get the point that I'm making here. But in addition to sort of knowing your audience, please note, if you're taking notes from this webinar today, please note what I said about showing graphs and charts, because I see a lot of experienced scientists make that mistake. Another thing, again, in this idea of not assuming your audience knows and sees what you see, there was a recent study from a colleague that I know at the University of Alabama that found that most people in the general public cannot point out their county on a map. So here's a map of the United States showing counties. And the study found that many people could not identify their county. Well, why is this relevant, Dr. Shepard? So a lot of TV meteorologists will show maps, for example, of tornado warnings and polygons and where tornadoes are headed. And if a person looks at that map and it has a polygon or a tornado warning over a group of counties and doesn't have them labeled, if they can't identify that county, well, that wasn't a useful warning for them. And so it's important, again, to sort of don't assume a level of understanding in our audiences. And in fact, assume about a 6th to 8th grade understanding is really what I try to target when I think about some of these things. Same thing with that sea level. That map that I showed violated this in a way, because it showed the sort of sea level rise for those SOBI indices, but someone independently might not be able to identify their county. So you really have to kind of walk them through or guide them through where their county is. If you're giving a talk in Chatham County, you want to even highlight or point out where that is. Tip number 2, avoid jargon. And again, this is an important thing, and I sort of alluded to it earlier. We often use terms that are very comfortable to us as scientists, things like uncertainty and bias and manipulation. But you have to think very carefully how the public hears those same words. As I mentioned, when we talk about a positive trend in carbon dioxide in the atmosphere, well, we know that that's a bad thing. But the person in the public sees the word positive as meaning good. And so they may think it's a good trend. A better choice of words would be upward trend. We know that the word bias actually might be an offset from a measurement. A thermometer may have a 2-degree warm bias, but the word bias to the public sounds like distortion or political motive. And so it's important to sort of be aware of these terms and jargony terms. Now, this particular graphic is from a really good article that I would highly recommend by Richard Somerville and Susan Hassel that was published in Physics Today. So I don't know if Rachel or someone, if you do a quick Google on climate communication and the names Richard Somerville, Susan Hassel, Hassol, you can probably find this. And so it's a really good link to have handy, a good reference for people. I want to open it up for a little bit of a back and forth here. Are there any other terms that any of you can think of that sort of have this sort of dual meaning in the science world versus the public that aren't represented? Is there some other word or sort of phrase that comes to mind? I think this is a pretty good list, but I'm just curious if you can think of anything else.
I did, Dr. Shepard, want to elevate a quick question from Rohan on this question. It was in the Q&A. Since the positive correlation might trip people up, is it ever better to show graphs with negative correlations when presenting a negative idea?
Yeah, I think that in some cases that type of sort of framing, Rohan, can actually be useful as long as you're sort of not using it to sort of present a minority or sort of a position that's not a consensus position from a science perspective. But yeah, from a contextualization standpoint, I think you're actually on to something.
We also got a question from Nancy, so I'm going to let her pop on over.
Hi, my name's Nancy, and I'm a doctoral of public health student at Georgia State. And one word that's tricky in the public health realm is surveillance. So the public might think of it as, being spied on.
Being spied on,
really, yeah, really just collecting information.
That's an excellent example, and I appreciate that you're sort of thinking and being aware of that. And so, I think we all have to sort of be aware of those kinds of words when we're talking to broader audiences. Tish, did you want to elaborate any more on positive and negative feedback? I noticed that you put
just that I suddenly saw it on your list.
Okay.
But yeah, I mean, positive feedback is one I try to use all the time, and it always causes problems.
Yes. Yes.
So I've started using runaway train, which people seem to get better.
Yeah, absolutely. No, I think that's right. And to Tish's point, find ways to sort of, convey the same point. Positive feedback's fine in our papers and in our conferences and so forth. But when I talk about a positive feedback or a tipping point, for example, even the term tipping point is very jargony. I'll use an example of a rubber band. I was like, everyone's played around with a rubber band, and sometimes you stretch it, or maybe we have a favorite pair of our pants that we wear, and we've stretched them. As people like myself have gained a little weight, and as I've gotten older, we've stretched that rubber band of those pants beyond their sort of point of elasticity, and they don't kind of stretch back or come back the way they used to. These are the kinds of things we talk about when we talk about exceeding tipping points and so forth. So, so it looks like Rachel has posted the Somerville Hassel article in the chat. Danny, I believe is how you pronounce that. What do you mean, Danny, when you say that global warming is frequently misinterpreted by the public?
I was just I was thinking about, especially when the term global warming was used more frequently than climate change, it wasn't uncommon for people to point out when it would be unseasonably cold, and they would say, if there's global warming, then why is it so cold?
Yes.
So I think shifting to climate change has generally reduced that misinterpretation.
Yeah, I think that's right. I often, if you've heard some of my talks and my TED Talks, I often say weather is your mood and climate is your personality. Whenever I get a tweet saying, hey, it's so cold today, what are you guys talking about global warming? I said, well, a day doesn't tell you anything about climate in the sense no more than your mood today tells me about your personality. I do have an article out there that I wrote in Forbes on this idea of global warming versus climate change. I actually the climate skeptic crowd has actually used that as a distraction. I actually use them interchangeably still, but I to your point, from a science communication standpoint, I think you're right. But the way I always sort of think about global warming is in the same way that I think about a fever and the flu, or COVID, if you want to sort of use contemporary terminology. A fever is it's just one sort of symptom of the flu or COVID, right? You have aches and sore throats and coughs and other things as well. Well, global warming is just sort of the most obvious symptom of a much broader problem. And so there was nothing inconsistent about, the use of global warming. Climate change just it captures the entire broad context of things that are happening, including global warming. That's kind of the way I always think about it. But I have seen some, that have more of a skeptic or denialist or contrarian slant that sort of try to use the frame, well, you guys changed the term to climate change because of the global warming stopped. Because remember, there are these things called zombie theories that I talk about from time to time. these things that have kind of been refuted by us as scientists, but live on in Twitter and at your uncle's table at Thanksgiving or in blogs and editorials, and like one of those zombie theories is, oh, it stopped warming in 1998. Well, no, you just looked at a cherry pick few years. You didn't look at the overall trend. So really good discussion here. So yeah, definitely keep in mind about those jargony things that we all deal with. So that's the second tip. So sort of along with that is it's sort of avoiding jargon. When you send out a message or when you're talking about science, stop and ask if your aunt or cousin who's not in the field would understand what you're about to say. I mean, that is the litmus test that I use for almost all of my science communication. I grew up in a small town in Canton, Georgia, Cherokee County, where most of the people have never seen an IPCC report or heard of methane or even been to a college for that matter. And so they're not going to sort of think about these things in the same way that I do. So I warn not to get stuck in the inertia of practice. And what I mean by the inertia of practice is, thinking about things from the inertia of what you would think about if you were in a group of your colleagues at the university or at a scientific conference. So for example, in the meteorology world, here are two very jargony type terms that you see thrown around even in warnings sometimes by the National Weather Service. You'll see particularly dangerous situation or PDS, or you'll see or hear the term eye wall replacement cycle. I look at those and immediately know what those things mean. But if I see those in a warning to the public and my uncle is going to read that, he has no idea what that stuff means. So that's important to sort of think about and sort of get out of the use of thinking about things in terms of our frames of reference or from the inertia of practice. Katie Foster says, sometimes I use the term climate disruption to avoid the climate has always changed dismissal. Yeah, that's a good way to put it, Katie, but here's what I use. I even use something more simplistic than that. I said, look, grass grows naturally and always has grown naturally, but when we fertilize the soil, it grows differently. Home run hitters, we just won the World Series last night here in Atlanta, can always hit home runs naturally, but when they use steroids, they hit more of them and longer ones. So that even resonates to me more so than climate disruption, which to me is also very jargony. I get the point of what you're using, but climate disruption, I know what it means and so forth. And there would be some, but I think people resonate with fertilizer on a lawn probably even more so than climate disruption. Even another one that people tell me, well, we always had strong hurricanes in the past. Absolutely. But one of the things I was like, trees always fell in the forest naturally too, but that doesn't mean chainsaws are hoaxes, right? I mean, trees can fall because of a human cutting down a chainsaw. So implicit in that, the basic sort of lesson of my response when I get that question, Katie, is it's not or, it's and. For too long, people presented it as naturally varying climate or anthropogenic climate change. It's actually both. It's both. And so it's certainly okay to frame it in those terms. But yes, thank you for sort of making people aware of the term climate disruption as well. All right. Third point, as we're marching through our sort of 9 key tips, and this comes from my colleague Kim Cobb and I actually hosted a workshop for the AAAS on science communication several years ago at Georgia Tech. And in that presentation package, we showed this graphic. This graphic is so important. This is one of the most important things I'll show you today, because it shows the sort of inverted triangles here. The one on the left is how you're probably being taught or teaching students. We teach students to produce theses and dissertations and presentations in which we give all of the background information, we give all of the supporting details, and then 300 pages later in the dissertation or an hour and a half later in the talk, we give them the results. When we're talking to the public or policymakers, you got to get right to the point. You've got to give them the bottom line right up front and then work your way backwards. So we have fundamentally sort of inverted sort of styles in how we are trained as scientists to communicate science versus how we should communicate it to the public. Now, I want to stop right here. Are there any questions or comments about this? Because this is very important. Any comments or questions? Okay, so I think you get the point here. Tip number 4, use analogies and metaphors as much as possible. Again, we saw an example of that when we were talking about climate disruption earlier. I mean, that's certainly one way to do it, but that analogy or that metaphor of grass growing with and without fertilizer, I think, for a large segment of the population would strongly resonate. And so I mentioned earlier this concept that I use, and I got this from my colleague, John Knox. I heard him say it one time in a class, and I've used it ever since. And a lot of people actually attribute it to me, but it actually comes from my colleague, John Knox. Weather is your mood, climate is your personality. So on any given day, you can have really cold weather or really violent weather, but the scientific literature does suggest that our climate is changing. So it's actually quite silly to me when I get it all of the time. I get tweets, "Hey, Dr. Shepherd, it's snowing here in Boston today. What are you guys talking about global warming?" And most of the time I just kind of ignore it. But if I'm feeling a little bit froggy and just want to kind of mess with them a little bit in a nice, fun way, I'll say, "Hey, it's January in Boston, you're going to get snow." But people sort of think about climate change and global warming within the context of, oh, we'll never have cold weather or snow again. Even in the year 2080, when our climate system is likely much warmer, we'll still have winter and we'll still have snowstorms. So point number 5, and I'm violating it today in this talk because I'm talking about 9 things, but when the literature has shown, and not scientific literature, but just sort of some of the communication and sort of psychology literature that I've kind of browsed from time, the literature has shown that people remember things in 3s. And so, it's recommended that you keep your points in 3s. Your 3 focuses on your research, 3 reasons your work is important, 3 research questions, 3 results you found. People are wired, for whatever reason, to remember things in 3s. All right. So here comes your first exercise. All right. So I'm going to pause for a moment. Get ready to write. Some of you have either done research or are currently doing research. Write down, frame your research in 3s. Now, I don't care if you frame it in terms of 3 reasons it's important, 3 reasons why you chose that research, but take about 5 minutes and jot down, maybe 2 to 3 minutes, jot down frame your research that you are currently doing or have done using 3s. And it can be any of these 3 or 3 things that I don't actually have written. And then let's come back and share. And as a part of that, remember the 3 M's concept. Keep them miniature, meaningful, and memorable. That's the 3 M's. So there's a company called 3M, if that helps you remember that. But when you're thinking about your 3 points, keep them miniature, meaningful, and memorable. So go, and then we'll stop and come back and share some of them here in a moment. Okay, maybe a minute or less. Want to kind of keep things moving. And by the way, if you are already done, please, if you want to sort of share, I mean, I want to have a couple of you share. Oops. Okay, again, I don't want to take up too much time. Is there someone willing to sort of share what you wrote, what you framed, and how you framed it? Don't be shy. I know you had some good ones come up. Okay, Julie, go.
Okay, I am not a researcher or anything like that. I'm actually 65 years old and I've just started college at CSU in Columbus,
Okay.
Georgia. And I've taken a few classes. So I don't really have any concept of what I think what you were talking about, but what is something that I have researched is I have twin sons with autism. And so I would say the thing that I have looked at with that is their daily living skills, their schooling, and what's going to happen to them as adults.
Okay, so that would be sort of the again, it's a little bit different than what I was looking for, to be honest with you.
Okay.
But it is kind of sort of thinking a little bit about sort of the three sort of things that are your central focal points when you're thinking about your kids with autism. So I certainly can kind of sort of see, you sort of still framed it in that way. So to a certain degree, I can kind of see how you kind of fit it into the box here. Max, why don't you sort of frame, I see something you wrote in the chat. Thank you, Julie. I see something that you wrote in the chat, but why don't you frame it a little bit so give us some context?
Sure thing. So the 3 points that I wrote down, and I tried to do this to sort of give like an overall structure of what it is I think about when I do research. So I kind of start with sort of the central issue, which is firstly, when crops get too hot, they produce less of the food that nourishes us. And then I went for the second point that kind of narrows in on like a specific reason this is interesting, which is that some plants are naturally more resistant to hot temperatures, but we don't know why that is. And then lastly, you sort of bring it to what I'm actually thinking about and doing, which is, my work is aiming to identify plants with resistance to heat and then maybe try to uncover the genetic basis of that resistance.
Okay, so I guess the question I would have though is I see these three things, but how would you frame the overarching statement describing what those three things are? These are the three whats. Are these the three reasons for your research? Are these the three outcomes from your research? Are these the three most important concepts for the public? I mean, so I see these three things, but I want to make sure we kind of, sort of answered the mail here a little bit. So, I mean, I see these three things that you were in, like that third one tells me what your aim is. And so how would you package what these three things are if you were in an elevator with a congressperson?
Oh, I'm going to need to think about that for
because that's kind of the objective here is to sort of teach you how to package in threes, not just list three things, but to kind of package. So like, for example, does anyone else have an example that they want to sort of that maybe kind of use to help us along here? Anybody else want to
Yeah, I might offer up one really quickly.
Sure. Who's speaking? Oh, that's
This is
Rachel.
Rachel.
Yeah. Hey, Rachel.
Yeah, when I worked with the Vermont Department of Health, they were trying to look at, the state had all these goals for transportation plans to try to shift people out of cars and get them to walk and bike more as part of reducing their carbon budget. And they were trying to come up with a good reason from the public health perspective to convince folks that this was a really good idea. So I did some research for them. And when I was talking with like stakeholders in the state, different community members, city leaders, all sorts of stuff. And I think what I was trying to get across to them was like, Vermonters love their cars. Like overwhelmingly, it's what they ride from the research. Two, when people drive their cars alone, it's bad for emissions. And it's also bad for their health because they don't move. And what we found from this model is if more people walked and bike, it would reduce emissions significantly in the state, reduce chronic disease, which also has huge healthcare savings. So like, I think it was about $30 million over a couple of years just in chronic disease reductions alone. It's a bit long. I think if I could workshop it, it could whittle it down more, but I think that was sort of the elevator pitch I would try to give folks when I wrapped up a summer work.
Yeah, and that's exactly the framing that I'm sort of getting at here, Rachel. Thank you, which is this idea that in that case, you were on an elevator with someone and you wanted to kind of quickly sort of convey sort of the three outcomes of that research. So you framed it in sort of the three outcomes and why it's relevant to the public. And so you had these sort of three kind of high level points. Whereas another sort of framing, for example, I do research on something called the brown ocean effect, me and my research group. And this is this idea that sometimes hurricanes don't weaken when they move over land. If there's wet lands or marshy lands or weeks of rainfall and the soil is wet, they think they're still over the ocean and they can still maintain their strength. We saw that recently with Hurricane Ida, which sat over the Ida. So, in an elevator speech on the brown ocean, I might sort of give a person three reasons why I'm doing the brown ocean research, or I might give them three findings from the brown ocean research that are important, or I might give three implications to society of what the brown ocean, how it affects society. So sort of binning those things, not just sort of listing three things. So I want to make sure we understand sort of these concepts of packaging in threes. Does one more person want to share? I think I've moved ahead here. All right. So, okay. Well, is Julie, is your hand still up from previously, or do you have something else?
No, I'm sorry. I guess it's up from previously.
Okay.
So
I just saw
I guess I click it again, maybe to make it go down.
No,
okay.
Yeah, you just click again and it'll go down. Yeah, absolutely.
Sorry.
No worries.
Sorry.
I just happened to see it there. So does everyone kind of have a sense of what I mean there by packaging things in threes and then also keeping it miniature, meaningful, and memorable? That's critical. It sometimes for scientists and scholars, it's difficult. That 3 M's is difficult, especially the miniature part. But again, and I see a comment or question in the Q&A, I guess Hannah's asking me to revisit Hannah, was there a specific question you had about that?
Hello, can you hear me? Oh,
I can, yeah.
Okay. I was wondering, how do you like when I see that pyramid on the right, how do you start off with supporting details, or
you don't start off, you start off with the results. That's what I mean by the bottom line. That's up front.
Okay. So then how is that different from the other one?
It's extremely, it's like completely opposite, because in a typical scientific talk, you probably are going to talk about what your scientific methods are, what your research questions are, and then at the end you tell. So for example, if I'm giving a result, a talk on how urban climate or urban environments cause the urban heat island, more than likely in a research paper or in a talk, you're going to kind of give the background on what an urban heat island is. You're going to talk about the data you use, what methodology you use, and then at the end of the talk or at the end of the paper, you tell them what you found. So that's the left side. But at the bottom line approach is, if I'm on an elevator or if I'm in a quick briefing, I said I would start off by saying, instead of saying we use the MODIS satellite data, land surface temperature product to determine, to answer the questions, are cities warmer than surrounding areas using a k-means clustering approach. That would be like the left side approach. The approach to the public would be, we found that Atlanta is typically 2 to 3 degrees warmer than the surrounding metropolitan suburbs. That's the bottom line right up front. And then I would then go into why we did that in the methodology. Does that make sense?
Yeah, so you kind of start out narrow and then you expand.
You start out with what you found.
Got it.
You start off with the result. Like what Rachel just said, she would start out with those 3 findings and then kind of backlog into what was the approach, whether they use focus groups or whether they use, longitudinal research, whatever they use. But the bottom line is what you present right up front, rather than going through the sort of inverted process of establishing the methodology and data, and which is kind of how we're trained as scientists and scholars to when we write or present. So is that more clear?
Yeah, that makes sense.
Okay, very good. Good. Thank you. Great question. Yeah. All right. So let's keep moving. The sixth point to remember when you are talking to the public, you are the expert. I like this little slide because it shows the different sort of perceived expertise in weather. You have Doug Hill, a TV meteorologist. You have myself and John Knox here on the set of Weather Geeks. You got the Farmer's Almanac. You got the groundhog, and you got people's aching knees. It's a storm coming. My knees hurt. All of these are sort of different framings of expertise on weather to different people, and people have different understandings. But one of the things I found out when I was at NASA, sometimes I would be asked to go on Today Show or CNN and talk about wildfires or tsunamis. And I remember telling one of the NASA producers, I was like, look, I'm a weather climate expert. I'm not an expert in tsunamis, which are an ocean phenomena. I'm not an expert in wildfires. It's like, Dr. Shepard, relative to the public that's watching the Today Show, you are an expert in that topic. And those areas that you aren't have expertise, don't feel free to say, I don't know. But I guarantee you know more about wildfires and tsunamis than the audience that's listening to you. So that's always important. Keep in mind that you are the expert, and don't be afraid to say, I don't know, or let me find that out. If you are speaking in an area that's not necessarily your kind of main area of focus. And here's a really important one today. It really should be like up around 1 or 2 or 3, to be honest. Use social media. Use social media. Use social media. I'm using my 3s here, keeping it miniature, memorable, and meaningful. The landscape has changed. Most of the public policymakers, they get their information about science from internet, and even increasingly from social media. This is actually an old graphic that stopped in 2012. I'm sure by 2021, this is up here somewhere in the 70 or 80% range. And so I actually get frustrated when I hear colleagues say, well, I don't use that new stuff like Twitter, or I don't use it. It's not new. It's been around forever. And it's a tool. It's not extra stuff. I mean, I briefed the House Science Committee of Congress 2 years ago about climate change. And the reason I was asked to brief Congress is one of the staffers for Senator Eddie Bernice Johnson, who is the chair of the House Science Committee. She said, oh yeah, you present really good information on Twitter, and I follow you, and a lot of the staffers here too. So the landscape has changed. We have to be in those formats. I mean, I know Rachel is involved with Georgia Climate Project and various things and has a really strong social media presence through that activity. We have to be. Now, there are some social media strategies, some do's and don'ts, just that I would recommend. And I spend a little bit of extra time here on social media because I believe it's so important. Make sure you place a disclaimer noting that tweets, posts, and photos are your responsibility and not that of your employer. Use social media for network and branding. Look at what Mikolaj John Piskorski said. My thinking about this space has evolved from social media to social platforms. The word media suggests broadcasting from one to many, but in research for his book, he found that people use these platforms to engage in many-to-many connections. So what he calls many-to-many connections, to meet new people or deepen their existing relationships. So the term social platforms better captures this reasoning. And I think this is important because, you know, I use social media to broadcast new information or new papers or studies. I use social media to follow hashtags right here when I can't attend meetings because people are posting key points and information from those scientific meetings. I use social media to make connections or to have discussions. I don't use social media to get in like long-term debates or what I call play Twitter tennis with people that just want to kind of debate for no reasons at all. Other strategies and do think about whether your post could cost you your job, your fellowship, or create hardship. It's okay to be provocative in social media, but just be careful and think about sort of use a self-filter, sort of always sort of self-filter and edit yourself. Don't post on emotion in social media. Do set preferences to monitor and control who can tag you or your words. Try to take the high road if you see controversial topics or things and you just don't want to engage. And do use pictures or images. Studies have shown that it's more effective in your messaging and social media when you use pictures and images. Here are some don'ts. Don't play Twitter tennis. Don't get in these back and forths with people. That was something I learned I will certainly sort of engage if someone has a misunderstanding or legitimately is wrong about something that wants to improve their understanding. But there are some people that just want to engage and get in back and forth with you on social media just so they can say, hey, look, I'm in a back and forth with Dr. Shepherd or this and that. Don't use profanity or words that can offend other groups. Don't post compromising pictures of yourself, and don't give too much cred or credibility to trolls. Learn to say thank you and move on. That's advice that one of my mentors, Admiral David Titley, shared. Okay, so there's a question in the chat or in the Q&A for Max. How do you overcome shyness when posting on social media? I often get anxious about putting my voice out there, and as a result have not put in the work needed to develop those skills. That's a key point. I often get that point when it comes to a lot of public engagement. People like, well, I don't have the same personality that you do, Dr. Shepherd, or I don't have the same comfort level. What I would say is that there are different ways to engage. I mean, look, some social media and some sort of internet based things, you don't have to you can write a blog, right? You can write that blog and just post it on Medium or post it on some space. And so your voice can come through and you just share that link to that blog and you said what you had to say. Or you can be very direct and engage, more so the way perhaps I do on Twitter sometimes or Facebook or on Instagram or whatnot. So I guess the question of that is find and leverage what is most comfortable for your level of personality. So this kind of gives you a summary of sort of the major. So I don't do much on Snapchat or TikTok these days, but on Twitter I use for engagement on weather climate topics, to promote new work or information, to engage with the media, which is huge. That's one of the things that I found to be quite big, to learn about new findings and papers, to expand collegial network, and follow meetings which I can't attend. Facebook is mostly personal stuff, although I do have a public figure Facebook page that's more science attentive. Instagram tends to be a little bit more personal. I frankly don't use LinkedIn very much, but I kind of use it as an online Rolodex. So a lot of people do connect with me on LinkedIn, and I do accept them, and I do connect with people. I just don't use it very much at all. I find it actually a little bit annoying with all the recommendations and, hey, congratulations on your work anniversary and all that kind of stuff. I occasionally write blogs and so forth. ResearchGate is kind of a good scholarly place to keep track of research publications and papers as well. So this is just a list of some of the social media that I use. All right, so your next assignment. All right, let's get ready. Take 5 minutes to jot down perceived strengths, weaknesses, opportunities, and threats of social media from your perspective. This is called a SWOT analysis, by the way, and you can see the graphic here on the right. So when you think about social media and science communication, from your perspective, what are some potential strengths, weaknesses, opportunities, and threats? So maybe list one or two for each of those boxes, and then we'll come back and discuss. Okay, maybe about one more minute, and then we'll dive in with discussion. Okay. So let's come back together. And so what I want to do first is to sort of get a consensus or a survey of what were some of the strengths that some of you wrote down. Just give me one from, that you wrote down. We'll kind of hopefully get, some different voices as well. Certainly some of the other voices that have spoken are welcome, but what are some strengths that you perceive of social media and science communication? And just feel free to sort of raise your hand. And Rohan.
Hello? Okay. One of the strengths, I think, is like the ability to reach very wide groups of people.
Mhm.
And if you sometimes do things with like videos, there's algorithms put in place that lets your things be seen by lots of people. So you could, in some cases, spread your information.
Yeah, you can viral it in a good way, as I like to say. Sometimes you want certain science to go viral. So absolutely broad audience and very wide distribution capacity. Yeah. Others, who has another strength that you wrote down in your strength box? Anyone else? Again, I can't see everyone, so I don't know if you're raising your hand and I just can't see you.
And we're still, don't be shy, folks. I know there's quite a few who's still hanging around. I mean, one is, I think it's being a part of an online community, or just, staking your place in a particular area of research. I've seen a lot of folks in public health really, join that community that expands beyond their, professional network within their own institution.
Yeah, great point, Rachel. And I see Tish put in the chat also, you learn new things from others that you were not aware of. Absolutely. Anna.
One of the things I was thinking about was that in something like Twitter, it forces you to be concise and to the point. So you basically have to just express the most important information.
Yes.
Which I think can be good. I think a bunch of us in science tend to want to explain every single thing that we're saying, but in a lot of social media platforms, especially something like Twitter, you can't.
That is such a great point. And I've actually given assignments in class before where I've actually, and I think the same thing is true of TED Talks, for example. I've given a few TED Talks over the years. They tend to be 10 to 13-minute talks, not these long, sprawling, hour-long things. That's why I love what the American Geophysical Union has done, the AGU, which is one of the professional societies. They have these things called lightning talks, and they're just really concise 10-minute talks and to help you convey. So I think that is one of the really, some people hate that about Twitter, but I actually love it. It forces you to kind of get to the point. All right, let's talk about what are some weaknesses. And feel free to jot any other strengths down in the chat, but what are some weaknesses that some of you wrote? I'll start with one. One is context. A lot of times people, one of the strengths can also be a weakness if you write something and people don't get the proper context for what was written. Hannah said it's up to the individual to decide on whether a source is reliable or not. This is an interesting point, Hannah, and this is one that when I was president of the American Meteorological Society, one of the big problems we were having in the AMS and in the weather world is that, everyone now has access to the weather models and weather information. So you might have some 7th grader in their basement eating Oreo cookies, putting out weather forecasts that are completely inaccurate. But, they're on Twitter and like someone may come across it on Facebook or Twitter and share like, hey, look, there's a snowstorm coming in 4 weeks. And well, we know that the models aren't good beyond about 10 days, the weather models. So there is so one of the things that I was actually proposing, it didn't really get a lot of traction for a lot of different reasons, is when I was president of the AMS, is a seal, some type of, just like the American Meteorological Society, when you watch TV meteorologists, they have the AMS seal. That means they've taken a test from the AMS and they have a degree. And so they're certified broadcast meteorologists. So I was proposing some type of seal that, meteorologists that have those same credentials could put on their profile pictures on social media. So that way, that you were getting credible information about the weather from those people. So that was something. It looks like Rohan said trolls, hate comments, and the general goons of the internet can sometimes take a toll on the person maintaining a page. Posts can get lost in someone's feed, so people will miss it. That's particularly the case with Facebook. I don't advise ever posting anything that has any time sensitivity on Facebook, because you might see it in 1 minute, 1 day, 1 hour, or 1 month, just the way the algorithm is configured. It takes time and consistent engagement. Katie says can lose the nuance of an idea. That's and maybe missing vulnerable populations such as older adults. Megan McLaughlin. That's and Sophie, posts can get lost. Yeah, that we already talked about that. Great discussion of weaknesses. Is anything else anyone wanted to say out loud about before we move on from weaknesses?
Oh, I was just going to kind of add on to what Rohan and Katie were saying. I find social media kind of exhausting. And I feel like you do have to be pretty consistent and stay on top of things. And that can be challenging, especially when you are a researcher who is very busy. And I know that some people kind of, especially if they're more promoting themselves as a brand, will hand off their social media to someone who actually does that as their job. But I think that it takes a lot of work sometimes to create a solid presence that is reaching a lot of people.
Yeah, I agree with that, but I often push back on that a little bit because I'm kind of an example of someone that probably has a pretty solid social media brand, but I also lead my department every year and publish funding and grants and funding and publications. So, you know, and maybe it just means I don't sleep, but I do. I actually have pretty good family balance in work life. But I guess my point is I am an example of someone that actually can do both, but I maybe just wired differently. My story isn't your story. So I don't say that to project, well, how dare you not be able to do both, because I can do both. But I guess my point is I do know a lot of scholars where it is they do both successfully. But to your point though, Katie, or I think it was Katie, you're absolutely right. I mean, I find, but again, I guess that's where my point is. I made earlier. I don't necessarily perceive it as extra. I don't see when I stop and do something on Twitter and post about climate or something that's extra because I'm supposed to be writing a paper somewhere. I see it as part of my scholarly engagement. Now, the reality is when you're in an academic setting or in a government lab, the metrics that are going to get you promoted or tenured or so forth are still how many papers did you publish, how much grant money did you bring in, and to a lesser degree, it just depends on what university at a UGA or Research One. Teaching certainly, teaching evaluation, things like that are important, but they may be a lot more important at a smaller university where teaching emphasis is stronger. So I do recommend that you definitely don't if the culture of wherever you are is such that they do see social media and in public engagement as extra stuff. We're slowly trying to change the culture at universities and ivory tower places thinking about that, but certainly be aware of that. And so everyone's wired differently. Tish said something earlier, which is true. I've always kind of been able to sort of juggle many things at one time. That's just kind of how I'm wired. My wife, on the other hand, really needs to focus in on things, and she's very good at what she does, but she has a very different approach. So, that is a key point. Other comments or questions? Okay, what about threats or opportunities? Let's just kind of lump both of those. Feel free to kind of mention either one. So Megan says an opportunity to provide a platform for discussion by going live. Often I see organizations conduct interviews live where the viewers can send questions and is essentially free. Yes, I think that's one of the most game-changing aspects of social media through Facebook Lives or through things like Zoom webinar. I guess this is not technically social media, but I mean, I think we're not only expanding access, but we're equalizing access as well, because some people have equitable or equal access to things and information that they may not otherwise. Opportunities could be to get jobs or influence or something like that, Amanda says. Great. Okay. That's a great point as well. Rohan says opportunity to connect with like-minded people or organizations that share some of the same goals. Absolutely. Threat, cancel culture. Megan, do you want to expand on that? What do you mean?
Yeah, hi everyone. I am Megan. I'm an ORISE fellow at the CDC. I see it, we all see it every day if you are on social media. One thing that is said that is interpreted the wrong way, or, a lot of people take offense to, or you did actually say something really offensive outright, can really just spiral. And the next day everyone is attacking you or canceling. Cancel culture is the term for basically you are shunned from society, essentially. And then afterwards, there's a lot of redeveloping or rebuilding that you have to do socially. And that may never happen. You might just be done after that. Essentially.
Yeah, no. Yeah, I don't actually like to use the term cancel culture because I think it's been kind of inserted into culture to sort of give people a reason to sort of say things they don't want to say. Or I think it's the new generation's political correctness terminology, which I also hated because, but that's just a personal opinion. But but your point is valid though, in the sense that it certainly can create situations where you got to be careful what you say or you can be called out and whether you unfairly or attacked. In some cases, you might be unfairly called out, but in some cases, you're probably rightfully called out. But the threat that I think you're making the point about is the threat is if you put yourself out there, you better be willing to suffer the consequences either way. Yeah.
And I think it keeps people from putting themselves out there sometimes, that fear.
Yeah, no, absolutely. I think that's probably one of the biggest reasons some people don't put themselves out there. Again, because they either just don't want to deal with it or don't have the time. And again, some of that is, in my case, I'm wired to be like, bring it on. I can I have kind of like a Teflon skin when it comes to things like that, but everyone's not. And so this is, Megan, you're making an excellent point. I think that probably is the number one reason, to be honest with you. Rachel says, even reading the receipts of tweets from long ago. What do you mean by that, Rachel?
Yeah, I mean, the idea, I think, of, people pulling, it's building off this idea of cancel culture, that you can say things, or have ideas that are, from 5 years ago, and it's going to come around the block, and either the science have changed, or the discourse around a subject has moved.
Yeah. Oh, I see what you mean. No,
and people are like, oh, well, you're supposed to be an expert, but let's look at this tweet that you had from, however long ago. Do you still how dare you? But you saw that sort of, I feel like, in a really compact format, almost with a lot of the COVID guidance, changing messaging on, no, you don't need to wear a mask. Oh, yes, we do need to wear a mask.
Yes.
And that's really hard. I mean, with anything, it's going to evolve, and public health guidance is just, I think public health folks have learned a lot during this.
Yes. I think that's right. I think that and I think Katie talked about groupthink and bandwagon effect, and Hannah just posted an opinion piece that came out. I recommend reading, Tish says, read Roosevelt's Man in the Arena speech. That's a great one, Tish. Thank you for putting that out there. And also came across a recent, this paper. Yeah, no, I think there's certainly, social media is a breeding ground for political polarization. And so absolutely, yeah, this is a great point. All right, I've got to move on because I just realized we're getting close to 5:30. But this was an amazing discussion, and hopefully you'll take this SWOT exercise. And by show of hands, or well, I guess we can't see all your hands, but I'm just curious. Hopefully, I wonder how many of you, this is the first time you've done a SWOT analysis. They can be useful little tools in discussion formats like this. So just something to keep in your back pocket as perhaps you conduct some of these things here in the future. All right, so let me move on. These are some additional readings that on sort of social media and the use of social media. Serious academics should use social media, my 9 tips article, and there's a Nature article as well. So these are some other things that, I think I'll probably end up making this available to Rachel and so forth, this talk, and so you can get those links. So I mentioned tip number 8 earlier, the myth, don't worry about this. I don't even think it's as much an issue for your generation perhaps, but there was in the past, some of scientific community had this idea that if scientists sort of went beyond the ivory tower, they were not serious scholars, and they were popularizers, the Carl Sagans of the world, the Neil deGrasse Tysons and so forth. They weren't considered serious scientists. And I was honored to be elected to the National Academy of Sciences just this year, and the sort of I guess statement for my nomination and election was for significant contributions in the science, but also changing the model of what a scientist looks like in terms of how they engage. And so I was actually quite proud of that, because it was my scientific achievement and scholarship had been recognized, but also this idea that I was fundamentally trying to change the mode of what an academic is. So I guess I say all of that to say that this idea of the myth of a popularizer is not really relevant anymore. And then the last tip, relate. This is a little acronym that I heard a scientist named Steve McNulty from NC State, North Carolina State University, talk about at a seminar several years ago, and it just stuck with me so strongly. He talked about that he worked for the U.S. Department of Agriculture, and he talked about how he deals with skeptical communities on climate change all the time, people like farmers and ranchers. And the approach that he uses is that when he goes in and meets with farmers or groups of ranchers or civic groups in those communities, he doesn't come in with his academic credentials blazing or his degrees or trend lines and fancy graphs. He uses this elf land concept. He comes in and establishes contact with the farmer or the group and says, hey, what have you been seeing in your farm? What have you been noticing about rainfall and drought on your farm? Then he listens. And then he finds common ground. Maybe the farmer has also noticed that they've been having more frequent drought. Well, that's consistent perhaps with what the science has said as well, but he doesn't throw that or shove that in the face of the farmer. He's like, oh, wow, that's really interesting. You're seeing more drought. So once he lessens mistrust, then he can assess the needs of the people he's working with, and then they can nurture and co-produce knowledge and deliver solutions and policy and so forth. So I think this idea of elf land and connecting to common value systems is important. So remember this elf land concept. And to give you an example of that, a few years ago, I was giving a talk to some congressional staffers from Georgia. And it was around the time there was a significant drought in California. And that staffer said, well, Dr. Shepherd, why should my constituents here in Georgia care if there's a drought in California? And so I connected I found a common value. This is a conservative, the staffer represented one of our more conservative representatives too. I found a connection value system that connected. I said, well, the reason Georgians should care is that, 99% of almonds are grown in Georgia. In California, 95% of US broccoli, 92% of strawberries, 91% of grapes, and the wine that comes from grapes is grown in California. So when Georgians go to buy these things at the store, at their Publix or at their Kruger, if there's drought and reduced supply, Georgians are paying more for those items. Aha, I connected with a value system, economy, the economic well-being of Georgians. And then I even went a step further and I said, well, as climate changes, why is it that California is growing 95% of broccoli or 90% of tomatoes? Or why can't Georgia grow some of those things too? So I created an opportunity cost in there too. So connecting with a value system is as important as listening and nurturing as well. So that's actually where I want to stop the conversation. I'm going to stop sharing my screen. And, for this last few minutes, if there are any just general questions or comments, I'm happy to take. You've been a great group, by the way, amazing engagement. And I really appreciate you all engaging. I mean, it makes I don't, as you can see, I don't like for this type of a webinar or lecture to be just me talking at you. I like engagement. So I just want to thank you all so much for actually engaging verbally and through the chat. So any final comments or thoughts? Okay, well, I think we might be at a point because we all had very good engagement throughout it. Hannah, do you have a final comment or is your hand still up from before?
No, I do have a question. So when I think during weakness, I mentioned about reliable sources, and you mentioned like the seal versus just like anyone putting out like a model out there. But I think like what I had in mind was that, for example, like with COVID vaccine, people actually don't trust sources or information coming from like the CDC, government agencies, and like scientific.
I see what you're saying. Even the organizations that we know are credible have lost credibility. Do you think that's a social media thing or just a political and ideological space that our society's in right now?
I think it's both, because, for example, like with COVID vaccine, like, for example, like if like what Nicki Minaj like went on Twitter and said about her cousin, and like what other like NBA player have said about the vaccine, like that seems to hold more weight. And I think it's both, that on social media those people have such a huge following, but also like political, like what you said.
Yeah, you're expressing something that my wife said exactly after Nicki Minaj said what she said. She said, you know, right or wrong, her voice is going to carry more weight than some CDC scientist or Dr. Fauci among the people that like her. And so that is part of the reason why I say, and it's going to take a culture shift. That is part of the reason why I say scientists have to become rock stars. And I mean that in an honest way. We have to become sort of be in that space so that our voices can compete with the Nicki Minaj's. Now, of course, we won't have 10 million followers like Nicki Minaj or whatever she has. But if we just kind of stay sheltered and shy in our average hours, those voices will continue to dominate. So we've got to infect the space.
Thank you for that.
Well, on that note, a good call to action to hop onto all those platforms. I know we've had some great feedback in the comments, and just a lot of thanks and gratitude to you, Dr. Shepard, for your time today in hosting this conversation. And many thanks to everyone who was able to hop on and join today. I didn't get to introduce myself earlier, but I work with the Georgia Climate Project as a project manager, and I know there's some folks who weren't able to attend today, so we're hoping to get a recording up of this later. But thanks again, and you'll definitely be hearing more from the Georgia Climate Scholars in the future as a part of the Georgia Climate Project. And huge thanks to Leslie, who's also on the line, who is instrumental in organizing this call today and really helping to help with outreach with students. So thanks again to everyone, and thanks again to Dr. Shepard for your time and expertise.
Thank you for inviting me. Take care, everyone, and feel free to reach out or on Twitter or email if you have more questions. Bye.